Hello guys and welcome to the channel. Today we're going to discuss about the differentiability in mathematics. Differentiability is a fundamental concept in calculus, which is a branch of mathematics that deals with rate of change and slope of curves. Differentiability is a property that a function can have at a particular point. It means that the function has a well-defined derivative at that point, which measures the rate at which the function is changing at that point. Differentiability is important in many areas of mathematics, of course in science, including physics, engineering, and economics. It allows us to analyze and optimize functions that describe real-world phenomena, such as the motion of objects, the flow of fluids, and the behavior of markets. In this topic, we'll explore the definition of differentiability, how to determine if a function is differentiable at some point, and important properties of a differentiable function. We'll also discuss the relationship between the differentiability and continuity. Now, to see if a function is differentiable at one of its points, we must see if a function is continuous at that point. For this, we have the three cases. The first case is that if the function is continuous, then it is not necessarily differentiable. The second is that if the function is differentiable, then it is continuous. And the third is that if it is not continuous, then it is not differentiable either. Now let's see this in two exercises. For the first exercise, we have a function of x, that is x for x greater than 0, minus x for x less than 0, and x for x equal to 0. Now the question is this function differentiable at x equals 0? Well, first of all, this function is continuous at x equals 0, because if we look at the unliteral limits, then they are equal. If you put the value of 0 here, and 0 here, we end up that unliteral limits are equal to 0. And now we see that if it is differentiable or not. Now let's make the first derivative of the function, and the first derivative of x is 1 minus x is minus 1, and 0 is 0. Here we see that the function is not differentiable because at the same point for x that goes to 0, the three parts are different. And in this case, we'll say that the function is not differentiable at x equals 0. Okay, let's see another example. We have the function of x, that is 3x minus 3 for x greater than 1, and 3 over 2 of x squared minus 3 over 2 for x less or equal to 1. Now the question is the same. Is this function differentiable at x equals 0? Where first, let's see if this function is continuous. As long as we have polynomial function, then this function are continuous throughout R or real numbers. Normally, they are also continuous at x equal 1. Now let's do the derivation of the function to see the differentiability. The first derivative of the function is 3 for 3x minus 3, and 3x for 3 over 2x squared minus 3 over 2. Here we see that the unliteral same limits are equal, and for x greater than 1, we have that the f prime of x is equal to 3, and for x less or equal to 1, if we put the value of 1 here, we end up that the f prime of x is equal to 3. As long as we have the same limits are equal, then this function is differentiable at x equals 1. Thank you so much. We will see in the next video.